this is just a short video about the simple machine incline plane. So here's an inclined plane. We have looked at the forces due to gravity of objects on inclined planes. The length of the incline is going to be d, and the vertical height through which you're trying to move an object is going to be h. So d is the length. Basically, it's a ramp. So if you're trying to move a refrigerator up into a truck, it's a lot easier to push it up a ramp than it is to lift it vertically up into the truck. So these inclined planes have mechanical advantages greater than 1. So this is length of incline, and h is the vertical height that you want to move your load. Okay, and we can see just from the geometry of that triangle that sine theta is h over d. Now, when you put an object onto an inclined plane and you want to drag it up the plane, forget friction, we'll just put the forces that we need. So the slippery slope component of gravity, if you remember, is mg sine theta. That is the force that you need to match in order to pull this up the incline. So that's your action force Fa. And so we can simply see that Fa is equal to mg sine theta. Now, the resistance, the thing you're trying to do is you're trying to take this load and lift it vertically through a height h. And so the resistance is simply the weight of the load, mg. Okay. And by definition, mechanical advantage is the resistance force divided by the action force. So you want to be able to lift a large load with a small force. And so mg divided by mg sine theta is 1 over sine theta. And 1 over sine theta is d over h. D being greater than h, this gives a mechanical advantage greater than 1. Okay, so basically, the price you pay is you have to drag it a lot further along the incline than you do if you were to lift it vertically, but it's a lot easier to do that. Okay, now, if we were to have a combined system, remember we did pulleys last time, so let's look at a system that is a pulley and a ramp, and an inclined plane, and see what kind of advantages we can get out of this. Oops. Okay, so we're going to put the inclined plane here. Now let's say there's a wall up here, and attached to the wall is going to be a movable pulley. So we'll go, let's see, how about we do it like this? Around and like this. And then here's a pulley. And the pulley then has a rope that attaches to our load. Okay. This is a movable pulley, so it's going to contribute to a mechanical advantage. So this is a height that we want to lift this mass through. This is the length of the ramp. And now, remember, the component of gravity is mg sine theta. That would be here. Should be here as well. So this would be mg sine theta. This would be mg sine theta. So as far as the pulley is concerned, the load on the pulley is mg sine theta. This is where you're pulling. So this is Fa, and this is Fa. All ropes have the same tension. Okay, so when you're doing mechanical advantages, you multiply the two together. So the mechanical advantage total is equal to the mechanical advantage of the inclined plane times the mechanical advantage of the pulley. So the mechanical advantage of the inclined plane is d over h, and the mechanical advantage of that pulley would be 2, because we have 2 ropes. So 2. Okay, and so that's how you would get the total mechanical advantage of that pulley with the mass. Doesn't even matter what the mass is. That's simply your mechanical advantage. So it all depends what the incline is. If you make it really steep, then D is closer to H. If you make it very shallow, then D is a lot bigger than H. It's a lot easier to pull, but you certainly have to pull a lot of rope. Okay, so that's fine.